just let me give you a quick overview of what we have prepared and in which direction we want to flow. So today we want to attack the tech field they choose shop. That's special for today. So we have you chosen that as a complex web application, which is getting more and more the actual situation, let's say, regarding web applications. So more like the model view controller style. So we have a decoupled front end, we have APIs in the background. It's getting complex. We secure that with our FortiWeb application, and just for curiosity, we put a FortiGate in front, as we want to provide segmentation in our cloud environment, and also use our Fabric integration for a bit more of a security layer to filter out what should be not in our demo environment. So we don't want to have real threats in our demo environment, right? That's what we want to go. That's our target for today, and let me start directly into our first part. Maybe you remember some weeks ago on the Cloud Field Day, I tried to break into Sricha's environment, tried to hack the SAP systems. And to be honest, it were horrible weeks for me because I tried it and tried it again. And yeah, some weeks ago, we discussed, hey, I need something new. I need something new in the surface. And she mentioned, sure, hey, let's do it for this time. I give you a second chance, right? Yeah. And yeah, so we have prepared some attack vectors, and let's talk a bit about them, right?
So before we jump into the demo, right? You've been trying to attack me since the Cloud Field Day. It's been a few months. And for everyone who have already watched that video, you know what I mean. But if you didn't, it's on the Tech Field Day YouTube channel, so you could go watch our Fortinet video again. So I think you should just stop it, sit back, relax, and drink some juice from my juice shop.
Yeah, I think that would be definitely a good idea, but no, I don't really want to be the idiot again. So let's go on that, right? So, and I start some different approach, right? So Sricha, I mean, she has a juice shop. So what can you do against the shop? So how can I attack against the shop? So I think one of the huge surface, which is often forgotten, are bots, buying stuff and reselling it for maybe some higher price. Remember, in the last couple of years in the pandemic, it started getting really interesting because everyone moved to online shopping. And maybe you remember PlayStation 5 launch. I think no one was really able to get one because the bots bought it and resell it on eBay for 3 times the price. I mean, it's a super win, right? For everyone, because they're making a lot of money and some other people's getting it from a different way. But that's definitely an issue because the reputation of Sony in that case is falling down. We have similar situations with graphic cards regarding Bitcoin mining and so on. And there are real problems in these bot space. And my idea is today, attacking this web shop, buying all the juice, because I want to make money, and resell it in my own shop, right? So that you don't get rich. I will be rich guy now. Maybe I then will buy your juice shop company in behind. So let me show you what I've prepared here. So I wrote a script, and that's a bot. So that bot will go over that web page, buy all that stuff, but stop talking. Let me show it to you. Let me run the script, and you will see some bot activity. So here you can see the Tech Field Day Choose shop is loading. You can see we move over, see what's there, clicking a bit around. And we know, okay, interesting stuff. Let's register an account. We are new here. Then we have to log in. But after that, we all know after logging in, okay, we need an address. We need some payment information. Let's add an address. Let's add some payment details. And let's move on. So, right, we are fast. So try to be as faster than human, because I want to get a product, not the humans. Let's put all the stuff into the basket. I hope we are not out of stock. Here we go. A lot of juice shops, some apple juice, also fruit press. I mean, I can do my juice on my own juice starting right now. And I checked out. So here we go. No juice anymore for you, right? Now it's mine. You can buy it from me. I mean, sure, I have now a lot, so feel free.
Yeah, I just wanted to give you some credit today, so I'll let you run. Let's just look at the attack log first, and then I would talk about what the feature of FortiWeb has protected, or what it's watching against. It didn't protect yet because I did let Julian go run his cool bot so that he could show off some skills. So here is that you see there is a, the attack log is showing, let me refresh this, some biometric space spot detection, right? And then I have this one with a no policy. I didn't have a policy because I let him go. And if you see, it's again a feature called biometric based detection. So what is so important about this feature, right? We all have blogs. We do, it's more of like our personal diaries where we put our information, interact with the users, they leave their comments there, and then we could text, we could talk or get some feedback from them and so on. But what malicious users like Julian is creating these bots and then trying to inject some information into our blogs. In the blogosphere world, it's more that we are not actually interacting with the users, but just the bots. And what harm they could bring, right? These are called form injection bots. And what harm they could bring is that they could create some transferable links and then inflate the search engine rankings. So these bots would have some invisible links in the background, and then that could improve their rankings. But at the same time, they could also lure the visitors because he's constantly giving some reviews there, putting some information and so on. So one way we all know, and we all know how to protect, is CAPTCHA. And I know all of us have tried CAPTCHA, and how many times did we get it right for the first time? It's super distorted characters there. You might want it to do twice or more to get it right, to make sure, or you claim you're a human. But think of it like every time a user has to come and leave a comment, then that's when they have to verify the CAPTCHA. So one disadvantage is that pretty annoying to type the CAPTCHA every time and verify it. So we don't want to have the CAPTCHA, but something else which is passively monitoring the information or the user traffic. So one way we could do passively is monitoring the web page, how the users are interacting with the web page, their mouse movements, their scroll, their touch, and so on. Like, are they clicking? Are they, scrolling the mouse, and so on. So that's called the biometric space detection. And even us as humans have biometrics for us, like fingerprints and so on. So it's just trying to scan that information, and FortiWeb is doing that for you. So if you go to this bot mitigation here, and then biometric space detection, I have a policy I created for Julian. And what I'm monitoring is the screen touch. Not only the screen touch, we also have mouse movement, click, keyboard, and scroll. So I set the event collection period to 10 seconds. So what it's doing is that it's gonna monitor the user traffic or user interaction for the first 10 seconds and see if there is a screen touch. Right now, I'm only monitoring for screen touch. And if there is no screen touch, then it's gonna block that request, or if we could alert it, we could deny. Or alerting is a good way to see what traffic is being targeted at our web policy. So we're just doing that. So this is a biometric space bot detection where it is actually passively monitoring the user activity and then blocking the bots like attackers like Julian made. So
that was the firewall that sees traffic passing through it, detecting what an end user is doing. How does that really work?
So how it works is when an application is being protected by the FortiWeb, it's going to induce a JavaScript. It's an embedded logger on the web browser, and the JavaScript is that's actually monitoring for the user activity on the web browser.
So it's sending, like the CAPTCHA does, right? Just passively.
It's passively sending the events to the server side. That JavaScript is doing that job.
Okay, very good. Thank you.
Now, do you want to try one more time and then see what you could do? Because
I can.
Let me do something here.
Okay.
So positive.
This time, try to shoot again.
Maybe I took your shot down. Oh, no, it's loads. Okay, let's run it again. Try to buy the stuff again. Register again. Ooh, that sounds, no, doesn't look good. No, that's it. I'm out.
Your bot is crashed because
that's it. You got me.
So initially I had no policy. I let you be in the monitor mode. So we did see that log where there was said there was an attack that was triggered. But now if I share my screen back and go to the attack log, this is the juice shop policy right now, which took into effect. And you see the no policy before, but this one is with the policy. And it's saying there is a lack of screen touch. And that's why that bot has crashed. So this is how we could protect and use the biometric space bot detection feature on the FortiWeb. So just to summarize here, right? What we have seen is that like biometric space bot detection did monitor for events like mouse movements and everything. But now I might get a question, what about the known search engines, right? Because Google, Yahoo, Bing are all good known bots and they are search engines. So what about them? So FortiWeb also have those search engines already predefined, and you could select to bypass those search engines. So any traffic it's seeing, the application is seeing from those search engines is bypassed and allowed and not denied. But you could also, you're not actually not allowing the innocent or not blocking the innocent client requests and known bots. So that's again another thing we have on the FortiWeb.
I think my next step will be next year I will buy a robot which is doing some screen touch. So.
Yeah, so just a question on that. So when you stopped the bot, what changed in the shop?
So I created like, we had two different policies. So there is called a monitor mode. That's the policy. So in the first time, the monitor mode is not blocking him, let him go, but we could see the traffic log so that as administrators in the monitor mode does know what is coming towards our web application. And then we could take certain actions. So that's a feature on the FortiWeb we offer that put it in the monitor mode so you could see all the user traffic. So you know what attacks are coming, but make sure you put back in the block mode. That's when any requests that are coming would be blocked.
Yeah, so so you're monitoring for activity, and then at the point you just it makes a decision and says that's a bot. And at that point you block it at the firewall. Did you change something on the website? How was the attack, or how was that activity stopped?
Yeah, so I can share and show it again. So there is in the policy here.
It's more where is the blocking action take? Like, is it a firewall rule gets changed and it says, no, that IP address is now banned? Is it, I've now inserted an extra check of say, you're probably not human, so I'll give you an extra hurdle to jump?
So how we did it, basically, you can think you get a block page. But now it comes to the complexity, because in our application, you have the decoupled front end. So what I did when I click, for example, a button, there will be an XHR request in the background. So like an API call. So the API call itself will be prevented. So the user maybe in that case doesn't even realize, hey, my request got blocked. So it depends a bit on your application, how visible such a block page could be. But there could be, for example, also something else. You could maybe redirect the user or maybe inject something different. It depends on the activity you want to achieve at the end for your users. You don't need to be rude as Sricha to me, for example.
Justin, to answer your question here, this is the policy which we are tying to the application here. Right, there is Juice Shop, there is Server Pool where the application is basically hosted, and the web protection profile is something which I created, which is a custom protection profile you could create to protect your application. So you have one or more applications, right? You could create this custom profiles, but not only that, we are offering some predefined protection profiles. The protection profile is something where you tie all the policies together. Say you want to do biometric space detection on this application, you want to monitor, you could do that. And the change I made earlier is that this one, the monitor mode, it's a turn on and a turn off. So when we turn on the monitor mode on this policy, what it's doing is it's just alert only, it's not blocking. But when we turn it off, that means it started blocking the request, it's in the block mode. And that's what changed when Julian tried to do it the next time. Does that make sense? Thank you.
Yeah, let me try something else. So I'm not out of ideas. I had a long time to think about it. So my next idea is, okay, doesn't work. My laptop is lack of screen touch, right? It doesn't touch. So I need another way. So, okay, hey, web applications, why should I, to be honest, the bot writing that bot took a lot of time, was really annoying. try to interact human activity, right? We normally do it out of our brain autonomously, but telling a machine to do the same is a lot of work. So why not crawling APIs? Scraping data out of that. It's there, right? Taking the direct do a request against the page and getting some data, or maybe send the request directly. Don't do that interactivity like clicking on a button and stuff, because when she's monitoring screen touch, that's not a screen touch, it's a different type of interaction. So what I did here is I created a script which basically gets all the products, gets the reviews. I want to also see the quantity, what quantity is available on these products, because I want to find some anomaly when Sricha is getting that shirt shoes per week, all right? I want to know the supply chain, that I can react on the right time to buy all the stuff when it's directly arrived. So to be honest, I could also hack the supplier, but different story. To remove the supply chain here. But that's what I want to do, and also want to extract usernames, because that's not the end of today, right? We have some more attacks upcoming, so I need some usernames and some stuff. So what I have here is I wrote a script to scrape all this information out there and eat it. It's quite simple. It's only eating it. So you can see scraping the data. So we eating it, feeding it in, and let that run. So will it take its time? I also put in some sleep functionality, just because a human never clicks that fast, right? I mean, you need to scroll with the mouse somewhere, and just to be a bit more realistic. And yeah, so Sricha, your data is going to me. It's
all good.
You definitely should take care of your security, right?
Yeah.
So we need to talk about that.
Yeah, at the end.
Yeah, exactly. So different beer time. Next evening at the bar. So the issue also with that now could be also something else. So I could, for example, inject reviews. And what a very famous is, I think you all know, you're having a blog page, and sometimes you, for example, use WordPress. How many vetting invites did you got already in the comments, right? It's a usual problem with bot posting stuff. And you can see, okay, as I zoomed a bit in, it's a huge table. It looks a bit crappy, but you can see we got a lot of information. We see here that OWASP choose shop card, right? For example, we see the products, we see some reviews, and if we scroll a bit through that page, you will also see, for example, here on the top, there's vendor. Oh, we have some usernames already also got. So we're getting information out of the shop, quite simple. And yeah, it doesn't block. So sorry, I have to tell you, we need to talk about your mitigations.
Sounds good. So like I said, you were hitting something which I have in the monitor mode. I think you should go back and try again, but give me a second again here, and I know what to do this time.
Okay, let me try it again. So here we go, same script, let it run again, same warning message. Let's start eating that stuff again. To be honest, it will work. Look at that. I'm getting data.
It's okay.
Okay. Let's see. Oh, it took a bit longer. Maybe some bit flips here ongoing. How is it going on your side?
It's going well here. Just waiting to catch you.
Okay. I'm getting more and more products. More and more juice. I think I will get diabetes after that talk.
There you go.
Okay. No diabetes today for me.
I just gave you some time, again, to give some credibility today. I'm not going to be as bad as last time.
Oh, yes.
So if we go back to the attack log this time, we see that there is a bot detection here. But this one was completely different from before. The earlier one was biometric space bot detection. This is just a bot detection. And you see here in the attack log, we see this pie chart or radar diagram here. And you see this various different parameters or different things which the FortiWeb is scanning for. So now the concept behind this is let's talk about it. So we have machine learning on FortiWeb, which Aidan mentioned before. We have every request would go through 2 layers of protection, the machine learning, and the machine learning piece is the bot detection here. So I enabled machine learning on my bot detection policy, and it's actually checking for various things. And the reason we have to do this is because before I mentioned about the form injection bots, the blog injection bots, where they come and then review and so on. But attackers like Julian have become very intelligent. And what they try to do is because they could write some bots which could actually decipher CAPTCHA, it could break CAPTCHA and then mimic as human. So those bots are called human mimic bots, trying to make sure that they act as a human. And the way it works is they're trying to make API requests this time, because he knew that I was monitoring for this screen touch and biometrics. So Julian made API request through his script, the curl request, and FortiWeb does know that there is some requests coming in, and he thought it was a human, right? But we still caught him at the end. Now, what happened here is that the human mimic bots are trying to do exactly as what humans did, make curl requests, grab some information, and they could use it in a wrong ways, accessing some credit card numbers. I don't know what you're going to do with it, but all of that passwords, everything is going to take them back and maybe sell it for some money and make some money there. So, but the biometrics paid bot detection let it go, like let it pass. It didn't detect it this time because he was a human. So what next? We need something else now. It's narrowed down to the machine learning. So in the machine learning piece, FortiWeb has collected some regular legit client information, the requests that are coming in, and you will see this model information here. So it takes the samples of regular clients, it will build a mathematical model here, and it's actually checking in this 13 dimensions here. So same as human. So what next, right? What next it has to scan for this request coming in. For example, if we see here, there is a TCP connection. So crawlers and scrapers usually create more TCP connections than the humans. So that's one thing which we could scan, and the HTTP requests coming in. So crawlers and scrapers make more HTTP requests than users, because users are just trying to do some legit stuff, click, 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 and just end that website or log out from the website. But what about Julian? He was trying to stay connected to us all the time, to the application, and then trying to get that scrape my web page. So it monitored for that HTTP request. And not only those, right? The human mimic bots, what they do is they forge and then the user agent, because when Julian is going to make a GET request to my web page, it's going to get some HTML content back. Now he will parse that HTML content, make a post request, and then he could use user agent. He could forge that information. He could forge IP address, he could forge cookie, and so on. He could do something trying to get more information from my, it's more like a crawler, which is going in into my web page, trying to get more information. So we need something again, which has to scan for those user agents, for the cookie, if that's legit, if it is really forging or not. So given the fact that we have this 13 different dimensions, maybe he would let it go with forging user agent, but not with the TCP connections, because we are monitoring for the TCP connections. And the machine learning is going to differentiate because it does know what actual model should look like, comparing it with this bot information. The other thing is, when bot requests these kind of doing some of the scraping stuff, they usually request for robots.txt file, which is invisible. And as users, we don't request when we make a GET request, we don't do that. But bots are going to see that robots.txt file. So that's useful for them in order to crawl and scrape information. So now it's going to request for that. Now, if you see these blue lines, those are all some nice, good traffic that has been to my application. But this one is something, the red one is an anomaly. And we caught that during our machine building. And this is something which is all FortiWeb is doing on its own, giving us this graph, nothing where the user is actually coming in and manually doing it. So it's ready here. So it did go through this various spikes. It checked that Julian has done, his bot is doing something else. Now, if we go back to the log report, now that we understood what the machine learning is doing, collecting the samples and now comparing it with the model which is ready, let's go back to the attack log here. if you see here, right, they have the minimum value, the average value, the maximum value, and the sample value. So the sample value is way high. Like I mentioned, the TCP connections are very high because scrapers do have more TCP connection, but the actual value, the minimum value, the maximum value are also mapped here. Like I could also take this off. You can see these are some maximum values which we allow that legit clients would do. And not only that, we also have some minimum values which the legit clients would do. So it wasn't the requests or the TCP connections, the HTML request, the head request he was trying to do, the HTML referrer information which Julian was trying to go against my application wasn't falling in this maximum and minimum values, but it exceeded. So the sample value is where we could click on these and see each of it information. And that's how machine learning has marked Julian as a bot. And it detected, even though you bypassed my biometrics-based detection, being super smart this time.
That nice red line that showed the anomaly,
Uh-huh.
is that detection, was that data collected automatically, or is it in a policy? Like if I just say permit IP any in some firewall policy, it's probably not going to collect all that, right? Because that's just a lot of overhead that it's going to be useless. So where is that actually configured, I guess, is the real question.
Yeah, so it is tied to the policy like before, but each of this
service in the policy.
Yeah. So if we go here to the policy, we have this machine learning policy here there. So this is a machine learning. So it's running. The bot detection is running. We're going to talk about the rest of them going on. But if you click on the view of this model, it takes us to the bot detection here. And then this is somewhere I set all of this information. I'm telling identify the client by IP and user agent, and then collect the samples, collect the information for a minute from this client. And then you could collect the information from this client, like 60 samples from this client per hour. And then we're telling just collect the 10 samples for the machine learning to build. I have set it very low because this is a demo and we want it to be quick for the machine learning to be run. But you see there is a huge range which we allow. So for legit applications, we would make it, the sampling should be more so that it could be an accurate model. Mm-hmm. Now, just to answer your question, we could also train this. Say I'm an administrator, I don't want Julian to be a real client initially or be part of my initial modeling. We could actually add the limit sample collection from my IPs. So I couldn't put in my IP address because I'm the administrator and I know how I need to train my model, just sending some legit information. So it will go build this model status. And at the same time, and I could also send some anomaly to test it or to see if it's actually detecting. And I did that. That's where it built this and started blocking for the requests coming on after.
Question from that model settings perspective, as you modify sample times and counters, is there any significant performance change with the application firewall at that point, or that's not any concern?
It's not any concern. The only thing is if you reduce the sample count, right, then the prediction is coming from this just 10 samples. So the accuracy might be very less, but say if it collected like 5,000 samples, that's more than enough what the application is seeing. So the false positives would be less, but just for the demo's sake, I set it to 10.
And is the compute for this ML model on the application firewall or somewhere else in the architecture?
It's on the application firewall. It's running in the backend. That's a machine learning engine on the WAF itself.
It's on the WAF, okay.
When you're saying that it's a machine learning engine, how it's detecting good traffic from, but like how's it building the model? Because that looks like a series of linear regression models.
More of collecting the samples and building the support vector machine algorithm, and then also at the same time monitoring for this 13-dimensional information, because it's building based on the support vector machine. It's plotting that on the graph, and then anything coming in, it's actually comparing with the model it has built.
You mentioned that it's running this on the WAF itself. Mm-hmm. Is it maintaining an audit log? Because I'm aware that there is a bunch of legislation coming around automated decision making. There are some interesting intersections with how that would work if I put this in front of some sort of system that, for example, let's say I'm a government and I put this in front of my web page for someone trying to access government services. and it thinks someone's a bot and it's wrong, how does that interact with my legal obligation to explain the decisions that are being automated and how that is made?
So the legal side, I can't speak on the legal side, but this is more of like the technology side. It's like blocking, and the audit log is something like, we do have a log for this attacks and the traffic, something which we could see and then prove, like here, when I went there, we do see what it's doing different. So this is something which we could prove why it's actually being a block, but I can't talk on the legal side.
No, and that's what I was after, is that that information about why it made the decision that it did, so that I can then export that at some other point, or I can go and just have a look at it and say, hey, it's misbehaving and it's actually blocking a whole bunch of legitimate buyers. What's gone wrong? Have I clicked the wrong button somewhere? Is the model gone out of sync? So it looks like that information is there. Hopefully it is exportable in some format so that I can go and analyze that in another system.
You could export it. We also have Fortinet internal solutions. It's a FortiAnalyzer where you could generate reports. You could do that, or if you could also export it to some syslog servers as well. So you have all of this logs. Right. Fun final time. I'm gonna just summarize this again. Defense mechanism is machine learning based bot detection now, completely different from the previous one. It's collected the samples before from the legit users, and then it actually trained the ML model from a trusted IP address. And now when requests are coming, it's comparing that trusted model with the new user traffic, and then it's blocking, and the FortiWeb is monitoring in 13 different dimensions, monitoring for TCP connections, HTML requests, if they're using user agent or not, and HTTP head methods, and so on.
Do you see that expanding into more than 13 dimensions, or let that develop over time? I'm sure there's some telemetry and data collection happening to determine whether you've got to expand or even contract that model.
I think that's what we have been doing from a few years now. 13 dimensions is something which we knew that the bots differ from the humans. That's what I would say. So if something new comes, right, if bots might be mimicking the humans, then we could add some other dimensions. But right now, those are 13 things which should be enough to see, is what I think.
Okay.
Yep. All right, Julian, I think, do you want to step back or?
No, I have a different approach.
Okay.
Next, new one. I want to be an unknown threat. Let's talk play a bit with some other ways. So as you maybe have noticed, we try, or Sreecha is that fair, and we use more or less only ML, no signatures, because signatures, it's too static. We need some more dynamic stuff, right? I'm also a dynamic person, so I'm going often from couch to bed and back. But let's try something a bit more, try something else. And I had a look already, to be honest, previous on that shop, so I could play a bit with it. But what about now, not talking about bots, talking about something like SQL injection, talking about other attack vectors on the OWASP list, right? There is by far more injecting stuff, command execution and whatnot, right? There's a huge amount of possible vulnerabilities there. And this could have indeed even maybe more critical impact, because if we get an SQL injection, I mean, as Sreecha mentioned, who wants to get a free credit card? I think everyone. I mean, to be honest, no one would say no, right? Or maybe to get some user information. We're talking about PII data. I mean, who knows, for example, the GDPR in Europe and Germany. If you know there's a data leak, as a company, you can think about, I will pay for it, or maybe I will close the whole company after that. It's the decision between those. So you try to be as secure as you can. And what I did, to be honest, I found an SQL injection. And that's the cool thing here. Mm-hmm. So I've opened already our Juice shop again. And when I've Burpsuit in the background open, because when you load that page and you have a look at the top right, there's this lens. So you can search for something. So let's search for a test, right? It's always, okay, we found something, there's a test, okay. Let's have a look in the background. What did happen here? Oh, look at that. There's a REST call in the background. But we didn't send anything, which would mean when we loaded the page, the data got retrieved. And now JavaScript is evaluating our test. So, but let's have a look. What does that mean? And Burp offers some cool tools called the repeaters. So we could send it with our stuff, what we want to show here at the end. And the typical one could be here now. Let's put in the classic one, single quote, right? Send it again, and let's see what is our response. Let me make the view a bit different, side by side. Okay, we got a success. Let's test it again with adding some plus and some minus. Comment something out. Send it again. Oh, that looks good. We found something. We have an SQL. Why are you using SQLite? You need a better database. So that's the first issue, right? We have to discuss it later on. But as you can see, the cool thing, also, by the way, disable error message is helpful. So anyhow, we see the select statement. So what we could do now is do an SQL injection. Okay, I'm a lazy guy. I'm a lazy hacker. Let's switch over to some tools. Let's use SQL map. Because that sounded a bit like also maybe like a blind SQL injection. I think everyone who tried a blind SQL injection, first time you do it manually. After that, you've learned you will never do it manually again. Using some tools is even better. I prepared SQL chip on our choose shop, and I know it's SQLite. And to be honest, just to speed it up, I know it's a blind SQL injection. Let's let it run, right? Just to be a bit faster, and boom, we got it. So let's move on. Let's find some tables here, right? So we can get rid of all that stuff here, and let's say, okay, I want to know the tables. I want to know what's behind that. And let's speed it up a bit. Let's set the thread count to 10. Have a bit of fun. So let's see. Okay, wow, users table sounds good. I think we're on a good track. Addresses, fantastic basket, products. Looks like, oh, cards. So, okay, as I mentioned, who want to buy some credit cards? Anyone interested right now? For free, you can get them. I think there will be one or two. So maybe free flights home or something. But you can see, okay, we got a switcher. So yeah, you definitely have a problem.
Yeah.
I mean, we need to talk about data privacy also.
I can address that.
Okay. So how do you think you could address this? Security questions.
We'll just wait and see what all you're going to get. And then I could show from my side what we could do.
It's interesting.
So again, I want to make it your day too, Julian, today. It's just not going to be my day.
You're so friendly.
Yeah. So I stopped and like my anomaly detection. So let me do something now again, because you questioned about my data protection and so on. Try it again.
Okay. Let's run it again. Just for preparation. Okay, let's see. Okay, that's not fair. Let's clean up quickly the files. I tested it previously and it worked. So here we go. Forget what you saw before. Let's run it again. Oh, wow, that takes quite long. It doesn't seem that good anymore.
That's right.
No SQL injection anymore. Okay, maybe. Forget about it. Let's don't try any additional temporal protection stuff.
We see this request coming in my attack log. And then this time it's machine learning, completely different from previous one, but it's saying an anomaly in the HTTP argument. So you see it's completely different. And we have this different graphs here, which are plotted. Before I get there, so the first thing is the feature of the FortiWeb, which is protecting this kind of an attack, is an anomaly detection. Because like we spoke before, signatures are something which we could always check for SQL injection, cross-site scripting, and so on. But there might be some false positives, false negatives there because it's comparing the regex. So we need something else more than the regex, something else. Now, in the we have a feature called anomaly detection. This is again using the machine learning, but it's going through, the traffic is going through two different layers now for the anomaly detection. So I have my domain, and in the machine learning, what FortiWeb is doing is it's learning about your domain, about the URLs, about the parameters of your domain, and building this mathematical model. And then anytime a new request is coming in, we can differentiate if it's a legit one or not, and then just take action, block based on that request. So I have this one enabled for the juice shop domain, just like we saw. And then we do see there is this a lot of domain data that is being, in the overview tab. So these machine learning events are automatically generated, and the machine learning runs through a few different stages. So first time when I train my model, it's going to build a model based on collecting some samples. Like I said, I'm the legit client to my juice shop. Obviously, that's my juice shop. So I sent some samples, like 400 samples is what we required with the deep learning machine engine we have on our latest version. So it collected this 400 samples of the information or the requests that are coming in. And I'll show you the diagrams and talk about it more. But from the FortiWeb perspective, what we are seeing is this machine learning events, it's going through this collecting phase where I sent 400 samples. And once it reached the collecting phase, it's going to move through this building, running, and discarded. Discarded is when the machine is a failure and no more is not going to take my samples, but rerun and rebuild this collection again. So in the running phase, right, it knew what the samples should be. It does knew what the values of this parameters should be on my web page. Now it should start comparing it and then block this information that is coming in, or if it's a 0-day attack, for example, we don't have them in the signatures because the signatures are built based on the known attacks. But what about just like something Julian has made up, which is a 0-day attack, which we don't know, and how are we going to protect? So once it's in the running phase, it start looking for the 0-day attack patterns as well. So then the other view which we offer is that it's actually doing everything. This is on machine learning, nothing manual. So it did see there are some requests coming to my REST, the root URL, the REST path, and the products, and so on. And then there is API, there is products. All of this is basically being learned by the FortiWeb. So search, right? That's what Julian have used. So if you see, we have this parameter Q, which he used Burp Suite and made that call, and it's in the running stage. So it means it knows how the samples should be. And at the same time, if you go to the parameter view, we do see there is this parameter which is running. And once it's in the running stage, we also see these different graphs, basically all making it a stats class now. See the graphs here. And then more information is that it collected 892 samples, more than required. And it keeps collecting because, like I said, the deep learning engine is not going to stop collecting after 400. But if it's seeing variations from the traffic that is coming in, it keeps relearning about the parameter. And maybe one day the developers of my juice shop would go and update some parameters. We don't need tuning at all. Nobody needs to go in there and make changes, but it's going to learn about that parameters again. So that's what the anomaly detection is happening. So now the background stuff, what we are actually using as an algorithm here, right? The machine learning is for anomaly detection, like we spoke, it's a layer 1 and layer 2. In the layer 1, we are using a hidden Markov model. Markov is a scientist from Russia. He has did this algorithm few years back, like many years back, and we use this algorithm in modeling in industry like machine learning, finance, and so on. So what FortiWeb is doing is it's actually observing the values that are coming in during the learning phase, where it's learning about my parameters, right? So I sent ABC as a parameter. It doesn't save the raw value in the machine learning, but it saves the character, like if it's a character, if it's a special character. So numbers and strings are basically classified as characters. So it sees as character. But when we see ABC alpha here at the rate here, it's going to see as a character and a special string. So this is what it has learned. And the 400 sample, it does know what the legit parameter should look like. Now, when we saw the last one here, the pattern FortiWeb is going to learn is it's a special character, and special character, and so on. But the Q should be something like a value. It's more an alphanumeric one, not anything like a 0-day attack value what Julian used. So that's what is happening in the building phase. Now, applying the hidden Markov model, right? The hidden Markov model, what it does is it predicts something based on observing states. So FortiWeb, what it knows is that we have combination of letters, numbers, and special characters to this parameter value. And it built this one telling that if you see a letter, And given the fact that the next parameter or the next character is going to be a letter, then the probability is 81%. That's more. Now, if it's going to be from a letter to number, the probability is 52%. And from number to number, it's 12%. So it did see, based on the build model, it does know about it because I sent 400 samples. It calculated this probabilities. But if we see the probability from number to special characters, it's like 2%. And what's the probability for special character after special character? It's just 1%, very low. So if the probability is very low, that means the score is high. So now we see ABC has low score. The other one, the 1, 2, 3 has a low score because, yeah, the letters, numbers, those are something which I've trained my model pretty good. But the third one does have a medium score because mine doesn't have special characters. The Q doesn't need, the search value Q doesn't need a special character. Now, what it comes to 0-day attack value, right? That parameter value, everything is special characters. We did see the low score, low probability there, and then ultimately giving it a high score. Now, do we want this to right away mark as an anomaly? We can, but what's that? We might have, more false positives, right? Because the ABC alpha, if FortiWeb is going to block it right away because it saw that it has a medium score, that's going to be a false positive. But it's just benign one. It's not harmful, even though that's not what my application should expect. It's not harming me in any way. So we don't want to have so many false positives and administrators having this huge fatigue of going through the attack log. So now we have the second layer now. So this high scored value has to be signed by someone that it's for sure it's an attack. So it goes to the level 2, which is a support vector machine algorithm. That's what we are using. And we do have some threat models already on FortiWeb, and it's really nice to see those threat models. I'll show you that right after this one. And we have given some weights for this value. Say, if the string is containing a single core, this is the weight. If it's a double core, this is the weight. And this is all given by our FortiGuard intelligence. That's our threat research lab. So they're giving this values, this weights for this incoming value. Now it's flagged as a high score. It's sent through this, and then it's vectorized. These values are vectorized, and then you see the combined vector there. And now it's going to send to our threat models, and not only that, our FortiGuard signature updates. Now, FortiGuard, I think for SQL, we have like 15 different weights based on the characters and so on. And those weights are not just static, but we keep updating them dynamically. That's something done by FortiGuard Labs. And it's checking that, okay, each string is now vectorized with a value. This vector value is going on to is compared through the threat models, and then see if it's an anomaly. Now, it said it's a SQL injection. But going back to the FortiWeb, and I wanted to show the threat models, how we have already, how our threat models are running. This is a well-trained mathematical model for cross-site scripting, and everything is done by our FortiGuard labs, like I said. So the incoming value, which was vectorized, is actually compared with this one. So it's again, support vector machine is very statistics. They'll take those values and draw a hyperplane and then calculate the margin to see which attack it's closely falling into. Is it close to SQL injection threat model? Is it close to cross-site scripting threat model, and so on? And then finding which attack it is. And if you see, it's super awesome to see all of this different threat machine models that are actually running. And it's comparing here with that. And these are, again, constantly updated by FortiGuard Labs. Nothing we have to do manually. And not only doing that, we see that it's comparing with the threat models, getting back. But what if the zero-day attack is a multi-dimension classification? Say the same payload might be a SQL injection one, might be a cross-site scripting one. So it also does see that multi-dimension classification and do some threat prediction for it and mark as an anomaly. The other thing, now let's go back to the attack log, applying whatever I said, like 2 different layers. We went through some statistics here. and see the anomaly detection one, this attack, it does know the argument value should be the green one. That was my sample values for the regular samples it calculated, and see how much difference is for this argument, the Fortinet score, the high score, it's like how much different it has to be from the actual value or the median value. So it did see, yes, it's an anomaly, but it didn't mark it right away. But we went to the second layer, the attack detection information, and it did see that it's a SQL injection one, and giving us this pie chart nicely showing it's a SQL injection payload it has matched. And it will also give you the matched pattern here. Now, when I told about multi-dimension, this one wasn't a multi-dimension, it's more of a SQL injection. But if you're seeing, maybe this one is a cross-site scripting too, or say a local file inclusion, this pie chart will also include those multi-dimensional threat models, and then boom, it blocks that request. So even zero-day attacks are blocked.
You started this by saying you needed 400 to get it to start. What's the ratio of how much better it gets at doing its job if it was 4,000 or 40,000? At some point, does it start to then tail back off again?
So it's not going to stop after 400. It's continuously improving its model. So say after 400, it's going to go until like it keeps collecting. It has to become a stable model. So that's what to put it nicely. So it will go to 1200. And every time a request coming in, it doesn't stop. The machine learning doesn't stop, but it's running, and then maybe say there might be some legit request coming in, and then it's learning something new about the parameters. Then it's going to learn about them as well. So until it gets stable, the 400 is something which we need for it to run, but it tries to stabilize that model in the background, collecting more and more samples. Yep.
So
go ahead.
So part of that, a question about if there is a significant development change to the website, is there the potential that it throws the model off? So does the model then become bypassed for a period of time while it resamples after a change?
Yeah, so during the building phase, that means it's bypassed because it's still learning. It can't just block it as an anomaly. But during that time, right, we do have known signatures that are going into effect. So if you already know those signatures from our signature database, it's being blocked. But if there is a parameter change, the FortiWeb is going to learn about the parameter, just that it doesn't know what the legit values should be. So we can actually train our machine learning model. So again, the same thing which I did is I made a Python script for this one and just train my model of what the values should look like. Okay. I told it to be characters and numbers. That's what I would like to have for the queue. So we could do that even in the real world, trying to train the anomaly detection. Or say you could only, for the first 400, when there is a parameter change, don't collect the samples from any different IPs, but only collect from this trusted IP. So if we go back here, there is a trusted IP. So when say the developers have made change to the parameter, FortiWeb has started learning, we could say the IP list type to be trust. So you could actually add that IP so that it's not building the model based on all the requests that are coming in, but will only build the model once it sees 400 requests from the IP which we mentioned.
Right. So I could have a situation where I've given QA dev a test policy, right? And could I then move a model between policies? So like if I've built a new site or made enough change to a site, right, that's going to significantly impact or a model change, right? Is there a way to share that or move that around?
You could export import it.
Yeah.
Export import.
Export it.
Yeah.
Perfect answer.
That's what I was going to show. So we have this export import. You could actually upload it back and
also as a backup. I mean, clicking on the refresh or, for example, this card is quickly done, right?
Yeah, we could do that too if you think.
And then I saw a rebuild button as well, I think. Okay.
Yeah. So if you think that the parameter has like so many false positives and maybe the model is not built right, that's could be the most of the time that could be the case. It's not built right, then you could actually do this, just do that action, and then it's going to start rebuilding.
Is there any protection, or have you covered some way of making sure that people don't spoof the machine learning, much the way that the Bayesian filters and spam filters were spoofed in the 2000s, where people would just send massive pieces of mail that had all sorts of sequences of words in it. So Bayesian filters would not be able to pick out what was appropriate spam. Is there any protection to prevent like a bunch of people or somebody acting like a bunch of different people and coming in and making requests that would be one-off requests that could seem legitimate, but
Like write a bot that just does a million things that are not normal, that makes it normal? Is that
that are innocuous but not normal,
yeah.
in an effort to attempt to
It doesn't trigger a bad thing. It just shifts the good model further down.
It's like an overflow to send 8,000 A's to make
well
it run
no
over,
but I mean be able to send a bunch of sequences that would be that later on 1,000 iterations down the line could actually be a trigger for something, but it's attempting to spoof your machine learning into thinking that these types of strings are somewhat normal.
So spoofing the whole machine learning model itself, like, because
I'm just it's a simple question based on the ways that people attack the spam filtering methods 20 years ago.
okay. I don't know about that, but the spam filter thing, but here the create new, like the IP address is something which I was like the way we could solve that problem is what I think is that we could just block those IP addresses from where they're trying to actually train the model, because they could spoof it or make the model to be act as for themselves, like whatever they're gonna send. So I think the best way is to just add the IP address from where it should learn. So when we have the IP address here in the list, then FortiWeb is only gonna trust that IP and build a model based on the requests coming in from that IP address. So if someone else is coming in and trying to spoof the model, train for themselves, then it's not gonna learn because I have the trusted IP in the list.
Okay. So you're saying that you only learn from one IP address?
We could do that, yeah.
Well, you could do that. So
not only one, but more than one. We could add those.
okay.
Maybe one thing to add, we're not only learning content, we're also learning the length, which means if you would now starting sending millions of line of text, right, which is a bit complex on an email because millions of line is small enough to send via email, but maybe not in a search functionality. Because, oh wait, that's an anomaly. Normally users typing, I don't know, 20, 30 long characters or strings in it. Now someone is sending 8,000. Well, something is looking a bit fishy here.
Well, again, I'm wondering if there's any way that it's protected against the idea that, okay, I'm going to send 20 today and I'm going to send 25 tomorrow and I'm going to send 30 and then, build it up to the length that would be needed. It's again, I'm just wondering, is this actual machine learning, or is this more of like a Bayesian, probability type engine?
I think that could be also matched with our next topic, maybe a bit, but it's definitely interesting a point, yeah.
So we have like DDoS policies, which we could create, telling to limit the number of connections from that single IP address. That's something which we could do, right? If it's constantly trying to send requests like 10 in this hour, 20 in this hour, 30 in this hour, we could just say only accept 5 samples in a minute, or limit the request.
I was in the business of making sure that you couldn't pick me up by IP address for a while.
Okay.
But it's something that certainly you can be capable of doing. And cloud providers make that even easier these days.
We have something for that. We're running also a bit out of time, which could help you to identify that. When you come from multiple sources, how many you can figure out? We don't have that much IPv4, right?
Okay, well, that would be a valid answer to part of this question. I was just.
So we have a capability, which we also have here, which can aggregate this information using machine learning to filter that out and put it together. to understand, okay, there is a threat coming from multiple sources trying to hide also from different countries and so on. To get it, okay, that's a threat now. We need to take care of that.
Okay.
There we have also ability. We're trying to be intelligent.
And
trying to get you.
Well, I mean, the problem is people who actually want to steal this information are equally intelligent.
yeah.
And
using the same technology. That's even also a point where machine learning and intelligence or AI, not only in the defense space is used, right? Also
Correct.
the offense side can use it. I mean, it's well-known technology, let's say that way, in the last couple of years.
So, and also there's bot, the TCP connections thing. Justin asked a question before, is the support vector machine here? The bot detection, this is something similar. The support vector is something which is being applied for the bot detection in the machine learning, which we saw, and taking those values, graphing that out and comparing it. So just wanted to add that. Just a summary is again, anomaly detection, machine learning here, run through different stages, learns about the parameter, and the whole intelligence here in the second layer is the FortiGuard labs, very unique to Fortinet.
Let's talk a bit more about also something different. So I hacked now into the system, right? Sricha got me, tries with bots. But what is definitely a point which is more also from an offensive perspective, talking about that is new web applications, as I mentioned earlier. We have the decoupled front and back end stuff. So we have a lot of APIs. And Aiden also talked about it, we have DevOps. So our application doesn't mean we patch it every month, so maybe there's a change. No, the development works continuously. So it could be your application is changing 12 times a day. Congratulations, feel free to secure that. And depending on how many headcounts you have, maybe you have 500 headcounts sitting there and putting in your API configuration in your web application firewall. I mean, that's super, but I would say that that's not the amount of how it should look like. And when we talk about this ever-changing threat surface and also with these APIs, I mean, for example, a huge case from my background in the SAP space, we're talking about SAP's moving all the stuff to web. So we're moving away from legacy. We now have also APIs behind OData and stuff. We need to secure it. We need to know about these. So now we talk about, we have shadow APIs, maybe APIs which are not documented. So, I mean, to be honest, who likes to document its own work? No one. I never met anyone who tried. I mean, either, right? I don't like documenting that work. So you forgot about it, right? Maybe to add it or something like that. So there are API endpoints which are used but not known. There is maybe internal APIs which are not that documented there. They're adding some new APIs over the day or changing the name or changing the functionality. And that's exactly a problem and a complexity which is in the security field and coming up in the last couple of years and getting more and more because we're also having more and more applications. Thinking about, we're talking now about Kubernetes. We have the ability to spin up rapidly in so many applications through a complex environment. It's getting bigger and bigger and all of that stuff, but you need to secure it. And that's something you should never forget about. And that's exactly what we have here with our FortiWeb. Sricha, please explain it. You can do that the best way. So we can learn about these APIs.
So before we talk about the feature of the FortiWeb, the API discovery feature, which is something new and it's machine learning again here. Usually REST APIs, right? They include like request and response. And just to go over what REST API is, that we will have a method, which is a post, get, put, head, and so on. And then we have a URL where the users will make API calls to. And the endpoint data, sometimes we send the data in the query, sometimes query as a query parameter, trying to query something back from the API endpoint, or sometimes we also actually post some data to the API. So it could learn some new stuff, create something in the endpoint with just the API call. So there is method, URL, endpoint data. And now when we make a successful API call, we get the response back as a 200 OK, and then the success with a JSON or JSON format back in the information. This is for the URL endpoint. Now, when I told about query parameters and path parameters and the body and so on, which is a JSON, we do have some challenges here. One is there might be an ambiguity in the URL pattern. When I say that, the ambiguity comes when if you know now there is a get request, there is this URL parameter, URL, which we saw like juice shop, and then user/A, user/B. So if you see this user A might be a single endpoint, user B might be a single endpoint in my API, or what if A is just a path parameter? So it could be an argument. So that's the ambiguity, right? It needs to, the API discovery should be able to see, is it actually a parameter? Is it something which is more of a variable that's being substituted, and so on. So that's something which it needs to know. The second ambiguity is, I mentioned about the JSON in the body. So for example, for our juice shop, there is user and then there is ID. And the user is a type string and ID is a number. So ambiguity in the schema of the body comes from when a post request is being made is, it could be a single URL request where the type is a string for the user, but at the same time, the ID could be a type number, which could be two different endpoints, but also at the same time, they could be derived from one single JSON, this whole dictionary, which has user and ID. Now, when we go to the ID, right, it's a type number. But what if type could be here? We see it as ID is 7 as a number. But what if the developers are also allowing SEVEN 7? So the API discovery should be able to see that as well. So those are some ambiguities which we have. And FortiWeb will be actually examining in 10 different dimensions, seeing the URL distance, path parameters, query parameters, and so on. And we will learn about your API endpoint, again, applying some machine learning in the back. So user traffic will come in, it will take the data, sample it, send it to our machine learning model, and it does know what it should look like, the machine learning pieces. Now it will apply some security scores, apply the API protection alert or block at the end. So if we see this in action, here, it's again the machine learning, it's learning about the API, but this time it's the API endpoints. And if we see here, there is this API users, which it has learned. And we do see, again, the roots, the API user here, and it learned about a post request because I was trying to create user through API. And it does know that there is an email, there is an ID is a number, email, and then password, and so on. And the cool part is it also builds this open API Swagger. This is nothing manual we need to upload. It does build it on its own. So anytime a request is coming in, it does just keeps building this. So you can actually export it, use the Swagger for something else as well. So your developers have that. So in this one, if you see email is there, password is there, email is a string, password is a string, is what my model knew. Now, if I make a request here through Postman, I'm just gonna do this really quick.
Can we start with a Swagger definition, actually hand you the Swagger definition that's come in from the new version of our website being built?
So any parameter that is being added, like if there is a new parameter that gets added to this website, it keeps learning based on the requests that are coming to that endpoint. And the Swagger is built on the fly.
But we can't feed a Swagger definition of what we're expecting at our API into this. It's got to learn it.
There are two different protections we have. This one is more of, I'm talking about the machine learning API discovery, but we do have a feature called API protection as well on the FortiWeb, where you can actually upload the schema and it will also, again, verify against the schema. So this is more like a step forward, which we took, where sometimes we do hear that they don't have API schemas that they could compare against. So that's why we came up with a plan that let's build an open API there. So here in my post request, I'm making to the API users. You all saw that that's in the running phase. It did know about my API user. And then I have all of this. So, and it did know that email is a string, which is a string. Password has to be a string, but most of the times people just set it as a pin. So what if the password is a string as a number, which FortiWeb doesn't want to allow because it's supposed to be a string is what we learned. So send this one. You're going to get the block page. This is the block page which we are seeing. And if we go back to API and then the attack log, machine learning open API request body violation. So it said that password is supposed to be a string. It's expected a string, but it found the integer. So that's why it blocked. So we could do a lot more, doing this, and it also sees the raw body of the requests that came in, all of this information. So as we keep making new requests, right, it will start going through that machine learning request. Let me also quickly make that request and show that. So I composed this GET request, which wasn't there in my list. And if I send it, I got, okay, 401 unauthorized. So I didn't have the better token. But if at all this have been a success, right, it did see that it learns right away about that new GET request. And it shows us this machine learning events where it starts building, collecting, and it says there is a new endpoint that it observed, and then starts collecting the samples and come into this building phase where the API users were and blocks. That's with our API discovery feature.
Super helpful regarding back to the development stage, right? If we talk about dev, we often have the developers build tests, if the API available, if they work. So you could take that there already and use, for example, the test machine as a trusted source, right? And automatically gets added to your open API. You automatically have your Swagger, and your dev guys can do more dev,
right,
and don't do documentation, for example, and you have it secured automatically.
And since you're really trying to intercept maliciousness, there's also the possibility that you could have a rogue developer that's compromised and may already know the new API, or right, could be adding an API just to be able to do exactly what you're talking about. And you would not really know that, right? And so I could even see this being very valuable for, we've been watching you for 6 months, and we would now like to know the rest of your network. Right. I mean, not to get forensic or anything, but, because that has happened at huge development shops.
Supply chain attacks, right?
Yeah. Yeah. There was actually an excellent article recently about AWS and how they don't even know where their data is, and how people were developing new tools to essentially shortcut people that, to basically do the juice shop style thing throughout the pandemic. It was quite intense. So I'm just thinking that would be another interesting application of this.
Yeah, definitely.
But
thank you. I hope we have maybe 1 or 2 additional minutes, because as I teased already, we have the threat analytics. And threat analytics is really new feature. So what we do with threat analytics is exactly what we discussed earlier. So we have a rise of a lot of alerts, right? We have a lot of information. Attackers don't sit, for example, in one specific country and using the home IP from their own router. You can use the cloud, spin up hundreds of instances and attack one target quite easily. There are frameworks out there on GitHub using exactly that. Fantastic, for example, used by bounty hunters. They're using such framework for large scans, right? Also, you have complexity in the attacks. I mean, when we saw earlier, ransomware groups are also learning their business and doing a better job. Exactly, for example, you could get context-less alerts. You get an alert, but you don't know why, what happened, what's going on there. Like, for example, sending a 1,000-character request. I mean, first of all, that's, wow, someone is sending me some text. Doesn't make a real of sense. And that's exactly where we jump in with our threat analytics. So what we do with that is analyzing these data, collecting them, removing that alert fatigue, putting that together, but on a different layer. So normally, if you would think about your SIEM, you're collecting information maybe from the same source, same day using all SQL injection or the same application. That's not enough. That's not what we really want to know, because that could cause a lot of false positives, or you would miss information. What we do here in that case is, let me jump on that. We take the source of the attack, which country, what is, for example, the HTTP agent. Remember the LinkedIn hacker who got into LinkedIn? He used a specific browser agent, for example, where they caught him with. That's exactly a point where you can get him. Also the attack type, or for example, the attack destination, what you want to attack. But what is always unique for an attacker, and I think we all can agree, if you learn how, or if you yourself trained how to, for example, do hacking, you will always do it the same way. You maybe will change it slightly, but you will always have the same methodology which you learned yourself. And that's something it's hard to get rid of. And we can learn that, and our machine learning is exactly detecting that. So we could, for example, identify APT group because they have always the same technology and the same way they attack you. Starting a scan, for example, and always the same routine. That's exactly where we can get on. For example, you try and always at the same time because you're scripting your attacks, always at 9, 12, and 1 p.m. sending these attacks. Okay, we learn after 1 or 2 days, okay, that's you. We got you. Don't forget we blocked. And that's exactly where we then aggregate this information, put them together, using the intelligence to find exactly these points, put it together, and represent it to you, to make it easier for you to find these threats and really focus on what is relevant and what not. And with all that said, let's try to be as safe as we can.
So
thank you for listening.
Thank you for listening. Didn't I tell Julian that he should just sit back and relax? So there you go. It's a Tech Field Day juice.
Oh, wow.
Juice
Thank
sponsor.
you. I got some juice.